I'm here on the official documentation for Babel. We use Babel to translate ES6 or ES 2015 code to compatible ES5 code that we can run in today's modern browsers. Babel has a lot of documentation on very useful stuff like, say, destructuring, default, rest, and spread. We've got let and const, of course, that old standby. And then we start getting into some more interesting stuff that you don't see quite as often on tutorials about ES 2015. Stuff like, say, iterators. And then today's topic, which is generators. So generators are definitely something that kind of mysteriously gets skipped out on a lot of ES 2015 tutorials. For some reason, like a lot of people don't talk about it too much. And I can give you a very good reason why. It's because generators are pretty tough to wrap your head around. Even if you read the official documentation here, it says generators simplify iterator authoring using function, star, and yield. Okay. I mean, that's not quite really explaining what's going on with them or even what's going on with this example right here. So let's spend a little bit of time to explore generators. And specifically, I want to explore generators around the topic of writing iterators, or giving us the ability to iterate through a collection of data. So let's talk a little bit about generators. I'm going to flip over to a little tool here that I authored to walk through generators. It kind of works like a REPL, but with a little bit of a twist. So usually with a REPL or a JavaScript REPL, you enter some code on the left-hand side, and then it executes it and spits out like the single result or some single result on the right-hand side. So this REPL of sorts has a little bit of a twist to it. If I define a function called, say, increment, and from here I return 1 plus number, I can now call increment, let's say 10. And I can put multiple calls on here. You can see that every time I call increment, I get a result over on the right-hand side. But now here's the interesting part. If I start changing the value, all the other results stick around, and only the number that I changed is going to update on the right-hand side. So I put in 4,000 here, maybe 30 here, 999 there, and -5 or 499, whatever, at the very top. And you can see that I get an instant update on the right-hand side. And then if I change the return value from 1 to, say, 1,000, all the numbers update on the right-hand side as well. So basically, any statement on the left-hand side that returns some printable value will be reflected on the right-hand side as well. So we're going to be using this tool a little bit to walk through generators. Let's go ahead and get back on topic, though. Defining a generator, the syntax is a little bit weird, definitely dissimilar from every other bit of syntax I've ever seen in JavaScript before. So to define a generator, we write the function keyword and then a star for some crazy reason here, and then a name for the function. The star right here can go either to the left of the function name or to the right of the function keyword. I've seen a lot of differing opinions on which side it should go on, so at this point in time, go with whatever floats your boat. Now let's add a little bit of content in here and then talk about what's going on with this generator. So I'm going to say const result equals 1 plus 1. So we're going to have just a very simple example here. And this is where things are going to get really weird. I'm going to say yield result. All right. So now this is looking pretty strange. First off, we got the star, which marks this as a generator. We still haven't really said what a generator is, of course. And we've also got this yield keyword in here as well. I'm going to go ahead and, without any real description of what's going on, let's see what happens when I say execute this function now. So I'm going to say const generator is numbers. So I'm going to execute numbers right here. So whenever I run numbers, it returns a generator object. And by convention, you can call this thing generator, gen, list of numbers. Again, I haven't really seen a lot of good convention on what to call this return value. So the first thing that you might be thinking here is you might be thinking, okay, well, we're running the function numbers. Well, we are executing 1 plus 1, and then, I don't know, something with yield, and we're adding 20 to it, so I guess maybe the result that we should get here is 22. So let's see what generator is. So when I print out generator, I get empty object over here. So I kind of had an expectation that we had to have a number as a result, but it looks like we get an object back, so that's definitely strange. So we can use this return generator object to manipulate or walk through segments of the code in here. So I'm going to call generator.next. And all of a sudden we get back a interesting value of 2, with another property of done false. So this is an object right here that generator.next is returning. So here's what generators are doing. Here's like the big summary, the big buildup. When we define a generator, we call the generator and call .next on the returned value. When we call .next, the code inside the generator is going to execute until a yield statement is found. Okay, that's like the interesting part. When a yield statement is found, execution of that function is paused. So let's kind of take a look at a diagram here and see if that can't help us figure out what's going on. So we've got this function called numbers right here. It's the generator. When we call const gen equals numbers, so we get some result being assigned to gen, it returns a generator object. So this generator object has the ability to step through the function with the next method. So we call generator.next, and it causes us to kind of step through the generator. We can call generator.value multiple times. And so the first time we call next, like generator.next, it's going to execute everything in the green code. So everything all the way up to the first time that we find a yield statement. Whenever we place a yield statement, if we place a value directly off of it, after it, that value will be returned from the first call to generator.next. And so that's what we saw here. We called generator.next, we called yield, that paused execution, and the return result was just result. And that's why we saw a value of 2 here, because we had result 1 plus 1, and then we yielded result. Now here's where things start to get really interesting and definitely a little bit less predictable. I can now call generator.next a second time to resume my function here, resume execution of my generator. So if I call generator.next again, you'll see that I end up with null. And so, hey, that's kind of strange. Why do I have null here? Well, I'm going to try passing a number here and just see what happens. So I'm going to pass in 10, and you'll see that now value gets incremented to 30 right here. So here's the really hard part to understand about generators. This is the part that's really hard. The first time I call next, the generator executes all the way up to the yield statement, and then it automatically returns whatever was yielded, in this case result. The next time I call generator.next, if I pass in a value, that value will be inserted in place of the yield statement. So when I make this second call right here, this generator.next with 10, you can kind of imagine that this highlighted portion right here suddenly magically becomes the value 10. And so we then return 20 plus 10, and the result is 30 over here. Okay, so that's in practice what generators do. We call next, it will run all the way until we have a yield statement. We can call next again, and that will pass a value back into the generator and continue execution. So you might be sitting there thinking, all right, well that sounds not very useful at all. Well, let's look at a little bit more complicated examples and then talk a little bit more about what's going on. So I'm going to delete all the code that we have right now, and I'm going to create another generator called list. Now inside of here, I'm going to put a bunch of yield statements. So I'm going to say yield 1, 2, 3, 4, 5. And I just got to change the numbers. So we're going to count up 1 through 5. 3, 4, 5. Now again, I can call a const generator with list. If I yield, or excuse me, if I next, first I get 1 because that's the value or what gets yielded by the first yield statement. I can call generator.next a second time. That's going to go back into the generator on this line of code, and it's going to execute again until the next yield statement is found, and the next yield statement returns 2, and so I get a value of 2. And I can say generator.next again, I get 3, and repeat the process, so on and so on until I finally get 5. And then at the very end, if I have no more yield statements and no return statement either, if I call next again, I get done true returned. And you'll notice that because I did not have an explicit return inside of here, I don't get a value on the very last time I call it. Now I can keep calling generator.next again and again, and it's just going to keep returning an object that says done true. So yeah, perhaps that's not, it's not the worst thing in the world if we keep calling next more frequently than we need to. So the idea here is that we can have multiple yield statements inside of a single generator. So why would we ever want to do this? And how does this all kind of tie back to the topic of iterating or iterating over a collection of data? Well, let's take a look at that. Let's see how things can get really interesting. I'm going to create a new variable, and I'm going to call it, let's just say numbers. And I'm going to create a for of loop. So I'm going to say for let value of generator. And so here's the generator, and we created a generator, which is the return object from calling the generator function. And now we're going to say let value of generator. And for every value that gets spit out of the generator, I'll say numbers.push value. And then finally, after the loop is all done, we'll print out numbers. So you can see that I get the value 1, 2, 3, 4, 5 from numbers right here. And so this is where generators start to get a little bit more interesting, a little bit more useful. We can iterate over a generator function, and for every yield statement that we have in here, my for loop will execute one time. So I've got 5 yield statements. I end up running the body of my for loop 5 times. Each time, the value variable in here is equal to whatever got yielded out of my generator. Okay, so you might be seeing this now and thinking, okay, well, all right, it looks like we can do some amount of iteration, but am I ever going to write like yield 1, 2, 3, 4, 5? Am I ever going to just like, spit out a billion yield statements? How is that useful at all? Why don't I just make an array? Good question. Let's expand this example a little bit and see what happens. I'm going to keep around the list for right now, and I'm going to make a separate list, which I'm going to call more numbers. I'm going to change the name of the first generator to just numbers as well. Okay, so now we've got 2 generator functions, and in the second one, I'm going to yield 3, yield 4, yield 5, and I think that'll do for now. And then up here inside of the first generator, I'm going to change this to 6 and 7. And I'm going to make something that's going to really throw everything into a twist here. I'm going to say yield star more numbers, like so. And then I'm going to call it. So again, we see this asterisk here. Now, without saying what's really going to happen here or what's going on, I'm now going to create my generator. And then I'll say make my for loop again, my for of. So let values, and let's get some new lines here. There we go. So for let value, and this could just be a const right here. So let value of generator. And then again, I'll say values.push value. And then we'll print out values. And so now, when I print out values, you see that we have 1, 2, 3, 4, 5, 6, 7. And so this is just another little feature, interesting one, that's going to help us with some more iteration. If we create 2 generators, we can nest generators or kind of delegate behavior here. So we went from yield 1, 2, and then we said yield star. And yield star specifically means, hey, I'm about to pass you another generator. The next time that someone calls next on this, go into that generator and execute it until we hit a yield statement. And so the result is we call numbers. The first time we call next, we get 1, then 2, and then we hit the yield that delegates to more numbers. So we go into more numbers. We get 3, 4, 5. More numbers has no more yields, so execution goes back out to 6 and 7. And we get the result 1 through 7. Whew, okay, so this is still really hard to see where this would ever be useful at all. Still doesn't feel very useful. So let's go to a real, somewhat practical example. Still gonna be pretty theory-based, but at least it'll be something neat, something you can show your friends. I'm gonna use ES6 classes to create a tree class. And so this will be like a typical computer science-y tree where we've got a head and then many children beneath it. I'm gonna create a constructor. By default, it'll have a value of null, and then I can also pass in array of children as well. Oops, I went back. There we go. So then inside of the constructor, I'll set this dot value equal to value, this dot children equal to children. And then we're going to do something very strange, very interesting in here. I'm going to create a generator that is a method on the tree, or I should say property on the tree class. And now inside of here, I'm going to yield just this dot value. So let's create a tree. Let's create a tree structure and see what happens. I'm going to say const tree equals new tree, and the head of the tree will have a value of 1, and then we'll give it some children as well. So the head of the tree will have first a child with a value of 2. The child of 2 will have its own child with a value of 4. And then finally, we'll also have a node on the tree with a value of 3. So essentially what we've got is the head has 1, it has children of 2 and 3, and the node of 2 has a child of 4. Okay, so we got some tree structure going on here. So I want to write a function that's going to iterate over this tree. I want to iterate over the tree and collect all the values of the tree into a single array. And I want to do it in a depth-first search fashion. So I want to go all the way down as deep as I possibly can and then start walking through the tree. So essentially, the result that I would expect to see here would be an array of 1, 2, 4, 3. That's what I expect to see here. Okay. So here's how we're going to tackle this. I have a generator that right now just yields the value of the head of the tree, or whichever node we're operating on here. So I can call it tree.printValues.next like so, and I get back the value of 1. That's coming from the head on the tree. But I want to iterate through the entire tree. I want to go to every node in the tree and step through it. So here's what we're going to do. I'm going to say for let child of this dot children yield star children dot print values. Okay, so now we got a little bit of recursive behavior here. If I call print values, if I call this generator on a single node in the tree, I will first yield that node's value. The next time I call next on it, I will enter my for loop here. As we just saw, we can delegate to other generators. And so for each child of this top node, of the head node, I will walk through its children and call print values on that node as well. So this is the big grand finale, the part where everything gets pretty interesting. At the very bottom, again, I'm going to create an empty array of const values, and then we'll make a for of loop for value of tree.print values. Notice that I'm just passing in the generator here directly. I'll say values.push value, and at the very end we'll pass out values. Looks like I got a little bit of a syntax error all the way down here at the bottom. Looks like children is undefined. My mistake. It should be this dot, or excuse me, it's just child, not children, just child, like so. Okay, and so you can see here that we get the result of 1, 2, 3, 4. So again, we created a tree. At the very top, or the head of the tree, was a node of value 1. It had children of 2 and 3. And then the node of 2 also had a child of 4. We called the heads generator of print values, and then we iterated over it. That means that we are now walking into print values, and we execute until we hit the first yield statement. So at the first yield statement, we enter the body of the for loop. We push on that value onto the values array, and then we walk back in to the generator. We then start iterating over the head's children, and for each child of the head, we're going to delegate to that child's print values function. And so this is going to recurse through all the different nodes, and eventually we walk over every node in the tree. So there is some practical use if you call walking through a tree practical for generators. We'll spend a little bit of time in the future to look at some other more practical uses of generators, because even walking through a tree perhaps would be a little bit easier with some very basic recursion. So We'll try to walk through a couple more realistic examples in the future as well. If you've enjoyed this video, I encourage you to go to rallycoding.com where you can learn more about the JavaScript ecosystem. I have one video released per week, and I look forward to sharing a little bit of knowledge with you.